if this was the phrase, catch me outside, how about that? You guys would remember it. But remember that if I say v of t is a function, right? Now what am I saying? I'm saying the velocity of time, velocity with respect to time, is a function that I use. In other words, this particle is traveling at 0.7 units per time, right? Now what that means is that because it's in motion, the antiderivative of this you could think of this as the derivative of the position. So what is the position? Well, s of t is equal to the antiderivative of v of t with respect to t. Okay? So now what does that mean? Well, the antiderivative of this, we got to think backwards. What is the derivative, or what's the antiderivative of this? In other words, what is it that I got to take the derivative of that gives me 0.7? And I believe that you guys already know that it's 0.7 t. And think about that for a second, look at it. Think backwards, right? Now, if you're not quite sure, that you'll make a mistake here from time to time. The one way to double check and correct the mistake is whatever you write down as the antiderivative, take the derivative of it. If I take the derivative of this, will I get this? Yeah.
Yes.
So what I have then is I have position as a function of time, which is 0.7 t. And the question says the particle starts at x equals 0, moves along the x-axis with a velocity as a function of time of 0.7 for the time greater than 0. What is the particle? Where is the particle at 6? T equals 6. So I just got to evaluate this. That's it. Does that make sense? All right. I went through and I don't want to say I over-explained it. The truth is I thoroughly explained it, but sometimes you guys just guess on these. Oh, there's two numbers. What do I do? Do I multiply? Do I divide? Well, in this case, we multiply, but there's a reason why.